good day. Okay, sa today, okay, so magkakaroon tayo ng examples on second order homogeneous differential equations. Okay, so in the previous video, napag-usapan natin, okay, we have talked about the three cases ng homogeneous differential equations which are in second order. Okay, so today, kakaroon tayo ng mga random examples. Okay, so without further ado, we will have our first example. So let's try solving this homogeneous second differential equations. Okay, so the best thing we can do is to convert this equation first to auxiliary equation. Okay, so in auxiliary equation, this y double prime is converted into r squared. This y single prime is converted into single r to the power of 1. Then plus 7 is equal to 0. Okay, so the next thing we should do is to determine the roots. Okay, so in order to determine the roots, there are two methods. Okay, we can do factoring or we can do the quadratic equation. Okay, so obviously by just looking upon the auxiliary equations, we can do factoring. So the factor of this is r minus 6 and then r minus 1 is equal to 0. So therefore, we will have two roots which are r equals to 6 and r is equal to 1. Okay? Since r minus 6 is equal to 0, so okay, so you factor it. So r here you can will become equal to 6 and r is equal to 1. Okay? So para hindi kayo malito, ganitohin natin. R minus 6, ganito kasi yan. Each of these factors should be equated also to 0. So r minus 6 and r minus 1 is equal to 0. So r is equal to 6 and r is equal to 1. Okay? So now we can have the solution to this problem. So the solution to this problem is obviously, kasya pa naman dito, okay, is equal to y is equal to c sub 1 e to the 6x and then c2 e to the x. Okay, so this is actually case 1. Okay, so the case 1 says, okay, so it has two real roots. So it has 1, okay, r1 c1 e to the r1x and c2 e to the r2x. Okay, so since it is only 1x is good as x. So this will be your answer. Okay, so if you want to know what are the three cases in solving second order homogeneous differential equations, you can also watch the video that I uploaded prior to this one. Okay, so if you I will just put the link on the comment section. Okay, so we will have another example. Okay, so this example, okay, so y double prime minus y single prime plus 24y is equal to 0. So how do we solve this one? So again, so we got to have an auxiliary equation. We convert it into auxiliary equations. It will become r squared minus 10r plus 24 is equal to 0. Okay, so y double prime is convert it to r squared, y single prime convert it to r, and then y, only y, convert it to 1. Okay, so since 24 times 1 is equal to 24. So obviously we can factor this one. So its factor is r minus 6 and r minus 4 equals to 0. So we have r minus 6 is equal to 0, r minus 4 is equal to 0. So we have r is equal to 6 and r is equal to 4. So therefore, our answer to this homogeneous differential equation is y is equal to c1 e to the power of 6x plus c2 e to the power of 4x. So this is your final answer for this second example. Okay? So please take notes that, okay, what is r sub 1 at what is r sub 2 is reversible. Okay? So pwedeng, okay, C1, okay, so it can interchange. Okay, so don't worry, it can interchange. So you can represent it as C1 e to the power of x and C2 e to the power of 6x. So these roots are interchangeable also for this number 2. So you don't need to worry if those two roots, you got it factoring reverse of what I have written. So it's still the same. You can get the same technically they are the same answer. Oh, your answer will be acceptable even if those roots are interchanged, not the same as how I solve it. So it's so ganon, interchangeable siya. Okay, so we have third example. So I will erase this one. So we have third example. So let's try this one. Okay. So again, we convert it to auxiliary equation. So therefore, it will be r squared minus 10r is equal to 0. So if you factor it, you will get r and then r minus 10. So r is equal to 0 and r minus 10 is equal to 0. So we got r, okay? R is equal to 0 and r is equal to 10. So how do you write its final formula? Okay? So we have y is equal to c1, okay, e to the power of 0x plus c2 e to the power of 10x. Okay? It's okay if you factor it the other way around, r minus 10 times r. So okay, so okay, it's just a representation. So e to the power of 0 is equal to 1. So therefore it will become just c sub 1 plus c sub 2 e to the 10x. So this will be your final answer. Okay. So let's add more. Okay. So we have fourth example. Okay. So what if your example was this? So we're going to solve this one. Okay. So auxiliary equation. Okay. So again, we'll try if this is factorable. Okay. So one thing, so if you are, okay, so if factoring, okay, so there are some equations in which there is no factor. For example, this one. So whatever you do to this auxiliary equation, you will not get factoring. Okay, so how do you know if this is not factorable? Okay, so you do it the same with quadratic equation. So the a here is 1, the coefficient of r squared. The b here is 8. Okay, so let's conserve space. So I will just put it here. A is equal to 1, b is equal to negative 8, and c is equal to 19. Okay? Okay, so one thing is, just like in your basic algebra, you do the discriminant. So this is the discriminant, b squared minus 4ac. If it is greater than 0, so if it is greater than 0, so you will have two distinct roots. If it is equal to 0, okay, if it is equal to greater than 0, it is two distinct roots. Okay, so just a review. So if b squared minus 4ac is equal to 0, it has two equal roots. And then b squared minus 4ac is less than 0, you have imaginary roots. You have two, okay? You still have two imaginary roots here. Okay? So that's the case of discriminant. So just remember this one. So I will erase this one later, okay? If b squared minus 4ac is greater than 0, it has two distinct roots. B squared minus 4ac is equal to 0, it has two equal roots. If it is less than that, if b squared minus 4ac is less than 0, it has two imaginary roots. Okay? So that's how it is. It's just a review. It's not part of the solution actually. Okay, so b squared minus 4ac is equal to b is negative 8, a is 1, and c is 19. So therefore, 64 minus 76 is equal to 12. So therefore, it has imaginary roots. It has two imaginary roots. Okay, so how do we solve this one rather? So we use the quadratic equation. So the quadratic equation is that r is equal to b plus minus square root of the discriminant b squared minus 4ac over 2a. Okay, so I will erase this previous example so that we can continue it here. Okay. So this is how you solve it. So we have r. So the r sub r here is negative of negative 8 plus, okay, negative 8 squared, which is the b, minus 4, a is 1, and c is 19, over 2 times 1. So the r here is 8 plus minus 64 minus 76 over 2. So we get r is equal to 8 plus minus the square root of negative 12. Okay? The square root of the discriminant over 2a. Okay, so you rather b, you can check it directly. If you get b squared minus 4ac, you just add negative b, okay, negative b rather. So, I'm sorry, I have forgotten to negative b plus minus b squared minus 4ac. So, it's correct. It should be negative. So, it will have 8. This is I, so it has a factor of 4. So, we can get 2 square root of 3 I over 2, or r is equal to 4 plus minus square root of 3i. Okay? So therefore, remember that formula for case 3. So this is case 3. It has these imaginary roots. So it has two imaginary roots. So therefore, we can solve the problem. Okay? So the solution will be in the form of y is equal to e to the power of alpha x over, okay, just a review, okay, so C1 cosine of beta x, okay, rather sine, okay, so we will put sine first, sine beta x plus C2 sine, cosine beta x, okay. So here, please, what is alpha and beta? So alpha here is the first coefficient, which is 4. And then the beta here is the second coefficient, which is square root of 3. So therefore, our solution will become y is equal to e alpha is 4x times c sub 1. C sub 1 is c sub 1 sine square root of 3x plus C2 cosine square root of 3x. So this will be your final solution to this problem. Okay? So it is quite easy. Okay? So that is how we solve auxiliary equation. Okay? Okay, so maybe we will have another problem or another example. Okay? So since this is a video, pwede nyong i-rewind tong video na to and then take the part in which hindi gusto nyong mas maintindihan pa. Okay? So by now, I will have another example. Okay, iwanan natin to. So ito yung problem natin kanina at yan yung final answer natin. So we'll have another solution, another example rather. So we'll have this example, number 5. Okay. So ano yan? Okay. So una, convert pa rin natin sa auxiliary equation. So this will be r squared minus 6r plus 9 is equal to 0. So paano? Nakikita nyo ba? Pwede siyang i-factoring. So since pwede na siyang i-factoring, so hindi na natin kailangan gumamit ng quadratic equation. So we got r minus 3 times r minus 3. Okay? Dalawang two distinct roots. So r here will be is equal to 3 multiplicity of 2. Okay? That 3, it was repeated. So therefore, it is case 2. Okay? This is case 2 in which 2 equal roots. So therefore, we get the solution is y is equal to c1 e to the power of the rx plus c2 c2x e to the power of rx. So you will get the r here is 3. So c1 e to the 3x plus c2x e to the 3x. So this is your final answer to this problem. Because it is case 2. Okay? The last example is case 3, the solution. Okay? So we'll have another problem. So what about this problem? Okay. So the auxiliary equation for this is okay. So this, okay, it will be r squared minus 8r plus 13 is equal to 0. Okay. So you might be thinking, okay, so in many, okay, so that's the explanation. Okay, so some of books, instead of using r, they are using m. Okay, so you can also use m instead of r. M squared minus 8m plus 13. Okay, and then mx plus c2x to the e to the mx. Okay, so they use m instead of r. So it is, okay, so just don't be confused. Okay, so some other just using m instead of r. So it's still the same. Okay, so one thing dito, if you cannot factor this one, okay, so you can okay, in order to check, you can check if it has two distinct roots. So the b squared is the b here is negative 8. So negative 8 squared minus 4. The a is 1 and the c is 13. Okay, so this is a, this is b, this is c. Okay, the coefficient. So therefore 64 minus 52. So you get 12. Okay. So this is not a square number. Okay, so this is not a square number. So therefore, because this is not a square number, so it has no, okay, it has no rational roots. So that's how you know it, okay? So one thing you can do is to get, okay? So if you are not sure with your solution, one thing is you get the discriminant. If it has no rational roots, if it is not a square number, the result is not a square number, so it has no rational roots. So therefore, we got to have a quadratic equation. So negative b plus minus b squared minus 4ac over 2a. So we all know that b here is negative 8. Negative of negative 8 plus, we know that b squared minus 4ac is 12. So square root of that one, 12 over 2. Okay, so I will use this portion. So therefore, we got r is equal to 8, positive 8 plus square root of 12 over 2. So the square root of 12 here is, we can factor out 4. So we get, okay, 8 plus minus square root of 4, 2, square root of 3 over 2. So you factor out, so it will become r is equal to 4 plus minus square root of 3. Okay, so it has two real and distinct roots. So this is case 1. So case 1 is y is equal to c1 e to the r sub 1x plus c2 e to the power of r sub 2x. So therefore, you will get c1 e to the 4 plus square root of 3x plus c2 e 4 minus square root of 3x. So you got, this is still case 1. Okay? So this, it has two distinct real roots. But the thing is, it has no rational roots. So this is how you solve second order homogeneous differential equations. Okay? So thank you for listening. I hope this video helps you understand the lesson better.